Lecture is based on map design and map composition. So for cartographic design, it's a partly mental, partly physical process in which maps are conceived and created. And it's driven by two goals. The first one is to serve the intended purpose of the map, and the second is to communicate the map's information in the most efficient way. So for our map purpose, what is the primary message of my map? Who is the map intended for? And who is the map audience? So you do have to take this into account when you are creating a map on what is your goal? What do you want your audience to know about your map? The cartographic design process, well, the first one is to determine how the map will be reproduced. The second, select appropriate scale and map projection. We covered our topic on map projection. On if you're focused in California, then you would use a map projection that fits California or another state or another country. The third one is determine most appropriate methods for data symbolization and classification. The fourth one, select which map elements to employ. The fifth, establish visual hierarchy. The sixth, create one or more sketch maps. The seventh is to construct the map in a chosen software and print rough drafts. And the eighth one is to allow intended audience to evaluate maps' effectiveness. So your map media matters when choosing a scale and projection. Is there a set scale and projection, or is it interactive? When choosing symbolization, what visual variables work well on paper versus on screen? Will my map be in color or grayscale? When choosing appropriate map elements, is a scale bar more appropriate than a representative fraction? And should all my elements be contained within the neat line? And when choosing a color model, RGB or for screens versus CMYK for print. So to select the appropriate scale and map projection, the mapped area should fill up the page and you should be zoomed in enough to see the symbols and labels. Your projection should be appropriate for your data. So using an equal area projection for distribution maps. Also, your projection should also be appropriate for the map location. So using UTM zone 15 north or using the USA contiguous Albers equal area for a map of Minnesota. So determine most appropriate methods for data symbolization and classification. So your visual variables describe the differences in map symbols used to represent geographic phenomena. So we're looking at size, shape, value, texture, orientation, and hue. And here we could see the 6 principal visual variables right here. So, and in this example as well. So I am going to draw. So when we're looking at the symbology of the point symbols, the line symbols, and the area symbols, also known as polygon symbols. These symbols here, point line and polygons, is an example of vector data. So remember, vector data is based on points, lines, and area symbols. So we could show a point symbol in a variety of ways. We could see it as size. We could change the size of the symbol. So the larger the circle, that means that the higher the concentration, the higher the number of that data point compared to a small point. And that means it's less of that data. And then we could see which shape. You could do different types of shapes when you create your map. If you want to do a point or a circle point or a square point, and you could change the gray tone value of your point symbols, and you could also add texture, and you could change the orientation of your point symbols, and you could change the hue. And the same applies to the line symbol. You can see the line width. Again, it's saying here there's a larger concentration of the data here compared to the small lines there. And the texture is different. So if you want to symbolize different roads on a map, you could say this one is a dirt road with that type of texture, or this one's a freeway road. Or you could do the gray tone value and so on, and the same with the area symbol. If you want to, again, do different sizes of the area symbols or the polygon features. Again, you could change the texture representing different land cover surfaces. And this is another way to look at it too in this diagram. So when you are creating the symbology for your maps, it's very important to take into effect all of these. And in your lab assignment, you will be working with changing the symbology of your points, lines, and polygons. And next, you want to select which map elements to employ. So what map elements are shown here in this example? Well, we could see we have the title here. We have our map showing us labels of the different locations here. And we have our legend. And note that our legend doesn't simply say legend, it says land cover. So it's great to change your legend name. It might automatically say legend. Delete that and put what is your legend about. Here we know this is about land cover, and they modified the names if needed so we could understand what each polygon area is. So when we see the dark green on the map, this is showing us this area, this region, has an evergreen needle leaf forest. We have our map scale here, and our map scale is showing us a graphic scale and our fractional scale. And we could see the source is least important. So we are seeing our source here at the very bottom of the map. So we are going to look at the map placement. So these are all important elements. So again, map elements, we're looking at the frame line, the neat line, the mapped area, the inset. So here it's saying this is the neat line. This is our border around our map. The mapped area is right here, and the inset is right here. The inset is just zooming in to the map. And then we have our title and subtitle, our legend, and the data source, scale, orientation, place names and labeling, and map symbols. So map elements also depend on the placement. So again, use descriptive titles, avoid things like legend and map of. So here's what I was talking about. You want to remove legend and be more descriptive. And the bibliographic and production data, so your source, where you got this, the source of your data, it should be in a subordinate position on the map. So again, it's in a position where that's the lettering is small, the size is small, and it's in the lower portion of the map. So our eyes focus more on our map and our title and our legend. So map composition is the arrangement or organization of map's elements. The importance of map composition, this forces the designer to organize the visual material into a coherent whole, and this stresses the purpose of a map and it directs the map reader's attention. So here's a map composition. So it's an empty available space to put our map. And we could see here our eyes immediately drawn to this large north arrow symbolizing the orientation of our map. And we don't even know what our map is about until we put our attention down here, and this is our title, Earwig Bites. So the placement of our map elements is not very good in this design. Our best position of the map elements would be A. We have our title nicely placed, front and center, and then we have our map uh, that's an appropriate size, and then we have our legend. Here our map is a little small, so that's why it's not appropriate. We want to make sure it is zoomed in at appropriate scale, like A. Here we could see our legend is being covered from our mapped area, so that's why this is not a good fit. And then here the placement of the map is far off to the side, which makes, and we have a lot of available space here that's not being used. Next, we are going to establish visual hierarchy. So that is what I've been talking about for these past examples, our eye movement and the optical center versus the geometric center. And we also have to look at balance, because we could see in this example, the balance is are far off to one side. So you want to make sure it's equally balanced like A when you're creating your map. So for visual hierarchy, this is the graphical representation in which symbols and map elements are ranked according to their relative importance. Important elements are graphically emphasized and less important elements are de-emphasized. So here, what is emphasized is definitely our graphic bar scale and our legend, but specifically our source. Our eyes are immediately drawn to the least important part of our map. So this is not a great example of our map element placement. Here in this example, this is a great example of the public schools in Lawrence. Again, this title is really small and we can't really see it, whereas this is a appropriate size, and we could see our source is de-emphasized. This element is de-emphasized. Again, the source is not really important to emphasize or pop out in our map, and our legend is appropriately symbolized. And then we could see our graphic bar scale. It is de-emphasized here. So the main important things that we want to look at when we see our map, again, is their title. What is our map about? What's the purpose of it? And then our legend. So the after is an improvement. So for our visual hierarchy, it's important. Our first visual hierarchy to look at is our thematic symbols, such as our title, our legend, our labeling, and our visual symbols. The second rank is our base map, such as our land areas, physical features. Our second and third importance is our credits and text material. Our third importance in our rank is based on water features and background base map material. And our fourth rank is other base map elements. So here is an example of the Vegetation Democratic Republic of Congo. And we could see here, this is the map on our left is the vegetation distributions for the entire country, and our map on the right emphasizes parks located in one forest type. So difference in visual hierarchy between the two maps is established mainly by changing the size of elements and repositioning them within the layout. So when we are looking at geometric center versus optical center, right here is optical center and here is geometric center. The designer should arrange the map's elements around the natural optical center rather than around the geometric center. So here in this example, we could see that the objects are placed more on the optical center. This is a map. Again, we have the map elements positioned very well. We have our title, Women in Government Decision-Making Positions in 1998. We have our legend here, percentage of women in government, ministerial or equivalent positions. So again, they removed the word legend and titled their legend appropriately to what the map is about and their classes. And then they also have percentage here. So when we are looking at our eye movement through map space, cartographers use this pattern when arranging map elements so that the positions of important objects on the map correspond to natural eye movement. So our eyes naturally move from the top to the bottom. Okay, so here again we have the focus of our eye movement. The most important information, like I said, is at the top, and then our least important information is at the bottom of our map. So here we could see our title is placed appropriately. We're automatically looking at our title, cocktails served, and then the least important is our projection and our representative fraction scale. So here, if we're using this map, we wouldn't know what the map is about when our eyes are adjusting naturally to our map. Instead, we immediately see our map, and then our title is at the bottom. So this one is the best map. And again, with this map, this is the city of Bloomington, Minnesota. And it's very important to balance out your map, the organization of map elements and empty space, resulting in visual harmony and equilibrium shows stability. So where you position the map elements in map space affects the balance of the map. Ask yourself, do the elements appear skewed to one side, causing the map to look heavy on one side? So we could see here that A is balanced, whereas F, we could see it's more to the side. And again, in this example, this map is more balanced than the other one. And we could see with this map, it's based on population density of malnourished children. And we could see there's a legend here, and the source is small. So again, de-emphasizing less important elements and emphasizing our most important elements, which is our title, map, and our legend. So the figure to ground method of accentuating one object over another is based on the perception that one object stands in front of another and appears to be closer to the map user. So this is showing us visual depth. Figures are important objects. They become objects of attention and stand out from the background, whereas grounds are things less important and are generally formless. So ground again is least important map elements, less important meaning, indistinct form and shape, and they fall back. Whereas figure is the most important map elements, more important meaning, and distinct form and shape, and they jump out. So here we could see our figure is the dog example, and it stands out more from our background, which is the dirt. And then here is another example of our figure standing out from the background. And the same thing applies when we are creating our map. We could see an A, there's a land-water contrast as a special case of figure-ground relationship. So our background, our ground is the ocean, and then our figure is our land mass. So the land mass is popping out. Whereas in B, the situation in which the water is represented as gray, this would be inappropriate. And C, we could see these are 3 levels of information established through figure-ground relationships. So we are seeing our ground as the water, our continents, and then our symbology of point features representing the size of the data in certain geographic areas. And here we're looking at visual differences. So this one pops out more than this example. So when we're looking at these two maps, this map shows the visualization of focusing on this county here because it is darker compared to the other counties. And this helps us to separate the figure from the ground. And detail is important as well. This is poor detail, and this is good detail. And we are only interested in this county, so we are focusing on the names only in this county, whereas here it's poor detail. We don't know which area to focus on. The edges play a role as well when you're doing visual hierarchy for your map. Here, this is a good example of the edges. We could see they are distinguishing this county by having a black border compared to the other counties that have a white border. So our focus is only on this county, whereas in this county, all the borders are the same. And layering is very important, especially when we have been working on our lab assignments. We have been moving the layers by pushing it above the other. So in this example, we have our graticule grids of latitude and longitude placed above our continent. So we can't really see our continent, whereas here they move the layer above the graticule grid so we could see our continent placed nicely. And so this is poor layering, and this is good layering. And texture is good as well to focus on your study area. So we could see the texture is the same in all of these counties with the little lines, but they made the texture different and separate from the other counties by doing this symbology of the wide stripes. And you could use shape as well. So here they used campground symbology compared to the circles. This map is the graduated symbol map of internet users in 2024 Europe. So you could see the oceans and the continents as well as the symbology of internet users. Here is a before and after of the Red Hill campaign. So this map is better. And then we could have a closer view of this, of the land ownership. So here we have our legend based on our polygon features, our line features, and our polygon features and water features. So again, we could see that with the waters, they made use of the texture. So for wetlands, they have like a polka dot texture, and then for our lake they have just a blue polygon, and then we have even texture for our streams. And with our transportation, they change the texture or the colors to differentiate between these different routes. So when you're creating your map, it's very important to look at these stuff. This is a map of global population density in 1994. And this is a parking ticket hotspots in LA. So you could see that they made LA County pop out with the green border, and then they popped it out with the orange symbology. This is the town of Fry Island land use map. And this map is the Big Sur Land Trust Carmel River Valley. So you could see they highlighted their study area in purple. This is a map of the generic names for soft drinks. So they're labeling Pepsi, Coke, soda, and other. And you could see that when we are looking at these different colors, they match it to the color brand. So you could also base your colors on your map legend based if you're doing brand. And we have death penalty execution since 1976. And a breakdown of the 251,287 diplomatic tables. And another map is the Minnesota's North Shore and Iron Range. So you can look at that in all these examples. They made use of the study area and the symbology of the data in different ways. Next, we're looking at color and typography. So color, what is it? So color is a visual attribute of objects that results from the lights they emit or transmit or reflect. Visible wavelengths are what we perceive as color. So we could see here the visible spectrum from UV all the way to infra. There are 3 dimensions of color. And we have hue, saturation, and value. Hue is the name given to the various colors we perceive. Each hue has its own wavelength in the visible spectrum, and this illustrates hues and their relationships using a color wheel. Most include 12 hues. In HSV, hue represents color. In this model, hue is an angle from 0 to 360 degrees. So again, each hue has its own wavelength in the visible spectrum. In cartographic design, we are not likely to have to identify more than 12 hues. So theoretically, humans can distinguish millions of hues, but not often asked to do this. The US Census tried 16-hue choropleth maps, but not widely used because it's too complex. Saturation indicates the amount of gray in the color space. It ranges from 0 to 100%. And when the value is 0%, the color is gray. And when the value is 100%, the color is a primary color. So a highly saturated color has little gray in it, a pure hue, and a faded color has lower saturation level, which means the color contains more gray. Like we could see here in this example, our hue is 220 and our value is 100%, so we see our primary color, whereas our value here is 70%, so this has a lower saturation, which means that it has more gray undertones. It looks more gray. Okay, so again, it contains more gray when it has a lower saturation. And value is the brightness of the color and varies with color saturation. So when the value is 0%, the color space will be totally black. with the increase in the value, the color space brightness up and shows the various colors. And in this example, our saturation is 70%, so it's colored, has a hint of gray compared to our saturation of 100%. So an abstract mathematical model describing the way colors can be represented, which is our color models. There are three primary models used frequently in mapping software. We have the HSV, hue, saturation, value, which we just went over, RGB, red, green, and blue, and CMYK, which is cyan, magenta, yellow, and black. So users can work directly with hue, saturation, and value, and they are commonly used in computer display.